Okay, thanks so much for checking in. We're going to take a look at matter and measurement. So problem 1 says how many significant digits are present in the temperature read from the thermometer illustrated to the right. So if we take a look at the thermometer, we see two different sizes of hash marks. The first size of hash mark is the long one, and that's showing between the 20 and the 30 mark. And then there are shorter hash marks that look like they're for every 2 degrees. So 2, 4, 6, 8, and that gets us up to the 30-degree mark. So if we're thinking about our significant digits, we always know that we go one past what we can measure. So in this case, we would be able to say with some degree of certainty that it was 27.5 degrees. And so that would be 3 significant digits. If we take a look at number 2, it says the dimensions of a rectangular solid are 8 centimeters long, 4 centimeters wide, and 2 centimeters high. If the density of the solid is 10.0 grams per centimeter cubed, what is the mass? So we know that volume is equal to length times width times height. And so if we take our dimensions and we multiply them together, that gives us 64.0 centimeters cubed. And so if we think about that in terms of the density, we can do dimensional analysis where we essentially multiply our 64.0 centimeters cubed times 10.0 grams per centimeter cubed. That gets us roughly 640 grams. We take a look at number 3. It says a metal sample weighing 30.9232 grams was added to a graduated cylinder containing 23.26 milliliters of water. The volume of water plus the sample was 24.85 milliliters. So which setup will result in the density of this metal? If we look at the options that we have here, we know that we have to take into account our change in volume. So that's 24.85 minus 23.26, and that's going to give us a total of 1.59. In this case, if we think about the volume unit that we're given, that's milliliters. And we know the density is equal to mass divided by volume. So we can say that our 30.9232 grams divided by 24.85 minus 23.26 would give us our density. So it looks like B is the right setup for that. Okay. Oh dear. Okay, hold on. Looks like we gotta go up again. So if we take a look at 4, the number of significant digits in 0.30500 is 5 because we have to account for the zeros that are in between the 3 and the 5 as well as after the 5. So that's E. If we take a look at number 5, a box measures 3.5 centimeters times 2.915 centimeters. So the product of these numbers is 10.2025 centimeters squared. What's the proper way to report the area of the box? So we have 3 significant figures, so that would be 10.2 centimeters squared. The result of 2.350 times 4.0 plus 6.311 is 24.2. So we have to be careful when we're adding or subtracting with significant figures. So we have to only take into account the values that we have. So we have 4 significant figures and we have 3 significant figures. So we have to go with the smallest amount, which is 3 significant figures. Number 7, a student does a calculation using your calculator and the number is 280.27163, which is shown on the display. If there are actually 3 significant figures, how would she show the answer? Well, in this case, she would have to use scientific notation, and so it would be 2.80 times 10 to the 2, or 280, which would be 3 significant figures. So,
282.
With the period after it.
Oh, wow.
The term that refers to the reproducibility of a laboratory measurement is precision. So that's A. Which measurement below is not written with 3 significant digits? So 2.00 is, so we can cross that out. 550 followed by the decimal or the period is, so we can cross that out. And 12.7 is, so we can cross that out. The only one that is not is 0.003 liters. That's 1 significant figure. We take a look at number 10. The number 6.33 times 10 squared is equal to 633. It's the same thing as 6.33 times 100. All the following are characteristic properties of phosphorus. So if we wonder which one is a chemical property, it's that when exposed to air, white phosphorus will burn spontaneously, but red phosphorus will not. So if we're going to classify each observation as physical or chemical property, let's take a look at number 12. So observation 1, bubbles form on a piece of metal when it is dropped into acid. That's a chemical property. Observation 2, the color of a crystalline substance is yellow. That's a physical property. Observation 3, a shiny metal melts at 650 degrees Celsius. That's a physical property. And observation 4, the density of a solution is 1.84 grams per centimeter cubed. That's also a physical. So there are 1 chemical property and 3 physical properties. Number 13, chromatography is a good way to separate the components in a mixture. You wouldn't necessarily be able to use chromatography to separate elements in a compound or atoms in an element, or the phases of a pure substance. The only thing that chromatography would allow you to separate is components in a mixture. When a pure solid substance is heated, a student obtained another solid and a gas, each of which was a pure substance. From this information, which of the following statements is always correct? The original solid is not an element. It must be a compound. So A is always correct. B might be correct, so that's where both products are elements. And C might be correct. That's the original solid is a compound and the gas is an element. D is incorrect. The original solid is an element and the gas is a compound. And E, both products or compounds, could also be correct. But in this case, A is the one that is always a correct conclusion. The prefix milli corresponds to what multiplication factor? That would be 10 to the negative 3, or in this case, the decimal. And then 16, a solution of sugar water may be defined as a homogeneous mixture. Although it looks like one's phase, it is a mixture. Wafting is the proper technique for smelling a chemical substance. That's D. You measure the density of a slab of lead as 11.10 grams per milliliter. The accepted value is 11.34 grams per milliliter. The percent error for your measurement, you would calculate by subtracting 11.10 from 11.34 and dividing by 11.34. And you would have to account for the 2 significant figures. So 2.1%. Number 19, which of the following elements is correctly matched with its symbol? Ni, nickel is the correct match. Fluorine is not Fl, it would have to just be F. And Mg is not manganese, it's magnesium. H is for hydrogen, helium is He, and Ag is silver, not gold. The marks on the following target represent someone who is neither accurate nor precise. So it's not centered on the bullseye and it's not close together. So you can check out the answers in total. Thanks for checking in. Appreciate your hard and diligent work to improve your chemical knowledge. Have a great one. Thanks again.